Hi everybody, it's Mrs. Hannafarth and I am here to take us through lesson 6, building quadratic functions to describe situations. We are going to be looking at objects being launched in the air. We are also going to be looking at quadratic functions and their graphs, and we are going to be looking at vocabulary words such as vertex and the zeros of a function based on a situation. So let's take a look at this picture I pulled out of Unit 4, Lesson 6. This was when we were learning about functions and graphs and the difference between the toy rocket and the drone graph. And I remember talking to my students about this, that we had a drone that got launched and then it hovers over the ground and then it glides back down, and we were able to figure out like where it started from, what time it was, how high it got up in the air, and then when it landed back down. And then even with the toy rocket, we noticed here on the graph that it started at about 25, it got launched at about 25 feet or meters in the air, goes up and then arcs down and lands after about 5 feet, or 5 seconds, sorry. So we are going to be looking at quadratic functions today, which is very much, or is, this shape right here of my toy rocket. So when I talked about that we're going to be looking at objects being launched in the air, we're going to be looking at a cannonball. So a cannonball is 50 feet off the ground. A cannon is 50 feet off the ground. It launches a cannonball straight up with an initial speed of 312 feet per second. We've got a function that's defined by this situation, and that is d is equal to 50 plus 312t minus 16t squared. And this gives us the height in feet of a cannonball t seconds after the ball leaves the cannon. So I want you to notice that right underneath there we've got this great graph. And I want you to just take a moment and notice some things about the graph and see if you can answer the question that asks, what do the terms 50, 312t, and negative 16t squared tell us about the cannonball? So the terms 50, 312t, and negative 16t tell us something that's going on in this graph. So we know by our information that was given to us that the cannon is 50 feet off the ground, and that 50 shows up right here. We also know from the graph that I could read this, that if this is 500, this is 100, so approximately right here is where the cannonball, or the cannon, launches the cannonball from. We also note that we are told that the initial speed, or the velocity, of my cannonball has an initial speed of 312 feet per second. And I'm going to note that that is noticed right here in the middle of my equation. Then it leaves us with the negative 16t squared. And I'm going to have to tell you that that has to do with gravity. So go ahead and jot those pieces of information down under question 1. So you can see that I went ahead and indicated 50 represents the 50 feet where I launch my cannonball from. 312t is the initial speed of the cannonball. I've got these two pieces of information directly from the problem. And then the last one has to do with negative 16t squared. That represents the effect of gravity. So if you think about it, you launch this cannonball, it goes up really fast, and then it starts to slow down. So then it goes up real fast, gets up there, and then right here it stops in a sense, and then it starts falling back down to the ground. So that negative 16 represents the effect of gravity. Moving on, question 2 asks us to observe the graph and describe the shape of it. And what does it tell us about the movement of the cannonball? So you're going to see that I wrote that it's curved, definitely, and it goes up and then it goes down. There's a couple other things I want you to note about this graph is that if you remember from our toy drone, right, or a rocket right here, we talked about that things were increasing and decreasing. Well, we have the same thing here. So this is the increasing side of my graph, and then it reaches this maximum point right here, and that's where it stops, kind of like, and then it starts falling back down, and this is my decreasing part of my graph. And this highest point has got a special name. That special name is called the vertex. So in a quadratic or this is also, the shape is called a parabola. So the whole shape is a parabola. So again, increasing, we reach the highest point. That highest point is called the vertex. Then it starts to decrease down here. Notice the shape of the parabola is going up and then down. There's two shapes of parabolas, but this one's going up and going down. So make sure you pay close attention to the vertex. I can actually write ordered pairs for the vertex because there's actually a point there. And then the other piece that I want to talk about is when does it hit the ground? It hits the ground right there. And so those are all pieces that we're going to look at on the next page. Question B asks us to estimate the maximum height of the ball that it reaches and when that happens. So take a look at the graph. Figure out what is the highest point and when does that happen. You can see that I indicated that the maximum height was 1,580 feet at approximately 10 seconds. It's actually less than 10 seconds, but I wrote approximately 10 seconds. I also want you to remember that the maximum height is also called the vertex. And if the vertex is a point on my graph, therefore I could write the vertex as 10, 1,580. So that's my ordered pair of my vertex. The next question asks us to estimate when the ball hits the ground. So we're looking at seconds. So go ahead and read this graph indicating when do you think it hits the ground. So you could see that I estimated the ball hitting the ground at approximately 19.8 seconds. Notice that I didn't use 20 because the cannonball actually hit the ground before 20. So then the last question on here asks us what's the domain that's appropriate for this function and explain your reasoning. I want you to remember domain are all of the inputs being the x values. So I want you to think about what are all the x values or domains that would be appropriate for this function and go ahead and explain your reasoning. So you can see that our input values would be anywhere from 0 to 19.8. And you're probably going, but wait, Miss Hannaford, you're going to notice that you can see that the graph falls before the 0. And I'm going to say, but that wouldn't make sense. So you have to look at values that would be meaningful. And so the appropriate domain would be anything from 0 all the way to where the cannonball hits the ground, which we said was approximately 19.8. So moving on, just to summarize, we've got another situation here where it just talks about the height of objects that are launched upwards and then they come back down, and we know they come back down because of gravity. So now we've got an object that's thrown upward, and in this case we've got this object that gets thrown from a height of 5 feet. It's got a velocity of 60 feet per second, and the height is modeled by the function right here of h of t is equal to 5 plus 60t minus 16t squared. Well, based on what we were told in this problem, we know that this is a quadratic. We know it's a quadratic, again, because of that exponent of 2. And you're going to notice down here, here's the graph of this function. And we can get some important pieces of information from this. First of all, we know that it starts at a height of 5 right here. We're told that the height is right there of 5 feet. We're also told that we've got this velocity of 60 feet per second. So that's how quickly this is shooting up into the air. We also know that this negative 16t squared represents the effect of gravity. Again, we saw that in the previous example with the cannonball. We also know that this is increasing. We also know that it reaches a pinnacle or a maximum point. We're going to remember that that maximum point is called the vertex. We also know that this side of the graph it's decreasing as it gets closer. Obviously, it's decreasing in speed as it's heading towards the ground. It goes up and then it's starting to go back down. We also know that right here, when it hits the ground, this is called a 0. And I can easily write the ordered pair of that. We know that this is approximately about what they say here, about 3.8. So about 3.8 comma 0. So that means that that's that horizontal intercept of the graph. So we also know that my domain is going to fall within the range here between 0 and 3.8. The shape, again, is called a parabola. And we're going to learn more about parabolas and its shape as we move through this unit. The other thing I just want to point out that the vertex is the point where your course changes direction. It goes from increasing to decreasing, or the other way around, depending on the shape of your parabola. Okay, so the last page, 6.4 Rocket in the Air, are going to be your Edpuzzle questions. I'm going to give you 4 multiple choice questions. So we're going to be answering the question based on this problem. The height h of a stomp rocket, which is propelled by a short blast of air above the ground, t seconds, is given by the equation h of t is equal to 5 plus 100t minus 16t squared. Here's a graph that represents h. Question number 1 asks us, how does the 5 in the equation relate to the graph? The 5 is the distance above the ground the stomp rocket is launched. Question number 2, what does 100t in the equation mean in terms of the rocket? 100t is the velocity or the initial speed of the rocket. It's given, if you didn't get that correct, you might want to go back through the notes of the summary that I just went over. Question number 3, what does negative 16t squared mean in terms of the rocket? Negative 16t squared represents the effect of gravity on the object. Again, if you didn't get that correct, you might want to go back and read the summary for this lesson. And the last question asks about when does the rocket hit the ground? At approximately 6.4 seconds, the rocket hits the ground.